Hello YouTube. In this video we're going to cover just a couple of application problems involving solving 2 by 2 linear systems. As a matter of fact, they're very convenient when it involves like say two unknowns and two equations. So let's take a look at a couple of very common examples. You know, the one in blue here, actually I'm going to probably catch some guff from some people because it's not that common, but the one in green is very common. So let's take a look at the one in green here first. Deals with finance. So part of this video is going to be me showing you how to construct the system in the first place, and then solving the system. Well, that's something that probably we're coming in with a lot of skill set already knowing how to do. So how to read these things, starting with this. You should always circle values that tend to be numerical. So reading through this, we say a total of $12,000 is invested in two corporate bonds that pay 7.5% and 9% simple interest. So we say, okay, so $12,000, 7.5% and 9%, and simple interest. You know, that's something that we calculate often in our exponents unit. So we say the investor wants an annual interest income of $1,900. Okay, so from the investments. So circle this guy. It says what amount should be invested in the 7.5% bond. So first things first. The last sentence. Let me give you a little hint here, a little tip. The last sentence always tells you what it is that they want you to find. Okay, so the thing you will be solving for. And in this case, we say the amount of the 7.5% bond. And we'll also say this with at least finance problems. You say that you always have a total equation. An equation involves totals. Okay. So now the last thing is this. You tend to try to match up units in an equation. So you know we're about to define our variables. We say like x and y. Okay. But we say x and y represent some values that we're looking for. In this case, we say what amount should be invested at the 7.5% bond. We're going to let x or y represent the amount of dollars in that bond. But you know, when you make your equation with x's and y's, you say, you know, you tend to match up your units. That is, you wouldn't say like, you know, so many dollars plus so many dollars equals so many degrees. You know, that wouldn't be something that would make a whole lot of sense. So when we say a totals equation, let's start with this. We define our variables. This is very necessary when you do systems problems. So we say let x equal. This is very important that you write number of. Okay, don't just write dollars, but we say number of, say dollars at, you know, we say 7.5% invested there. We say let y equal number of dollars at 9%. So now we have these defined. Just know that, you know, if you were to define them backwards, you're still going to get the solution you're looking for. It's just, you know, it's going to change the way your graph looks if you were to graph these and how you would solve it. So we say, now that we've got this, we say we need a totals equation. So think about this. We say we have a total of $12,000, and since x and y represent dollars, we can make an equation that, you know, say it's x plus y. So we say dollars at 7.5% plus dollars at 9% equals total amount of dollars. And actually, I'm not even going to write the dollar sign, but we say 12,000. I'm not even going to write a comma. $12,000. Now we can say check. Got my 12,000 out of the way. You see the numbers that are remaining are 7.5%, 9%, and $1,900. Now $1,900, you know, it's just me. I've got a hunch here, but I think this is a value that's going to go on the right here. But we say that represents our interest income. When we talk about interest income, well, first of all, let's talk about what we mean by 7.5%. We say for every dollar, you know, you spend there, you're going to get 7.5% of that dollar on top, you know, back. You know, the 7.5% of the amount you invest at that account back in interest. Okay, so we say, all right, so if I want 7.5% of the amount I invest there, of in math, you know, like and means plus, of means times. So we're going to take 7.5% times the amount of dollars we invest at that, which was our variable here, x. Now, key thing here is this. When you say 7.5%, of course, we're not going to leave it like this. We have to convert this to a decimal, so 0 point something. But remember, going from a percentage to a decimal, we move the decimal back 2 spots here. So we've got like an empty spot here. This would be the same thing as 0.075. So we say, okay, so 0.075x plus now 9% of however much we invest at 9%. So this would be 0.09y equals 1,900. So now, solving this system, you know, like the skill set we have already, let's go ahead and eliminate the decimal in the second equation here. We'll just take the second equation, since we have to move the decimal right 3 times on our 0.075, we'll take it times 1,000. So essentially we get this system now. We say x plus y equals 12 grand, And if we shift the decimal right 3 places on all of our values in the second equation, we get 75 now x's, plus shifting it right 3 times on this one, here we get 90 y's, and 3 times on our 1900, that would just essentially add on 3 more zeros there. Now we can solve this system, and I think that elimination method would be as good as any other method. So we say, well, let's take our top equation times negative 75. So we get this, we get negative 75 x's on our top equation, minus 75 y's. We have to go check our multiplication here on our constants, but our second equation we have 75 x's positive, 90 positive y's, and 1, 9 followed by 1, 2, 3, 4, 5 zeros. So now 12,000, we need to take this times our negative 75 here. So we're going to go over here, we say 12 grand times negative 75. So we get this. We get an even negative 9 followed by 1, 2, 3, 4, 5 zeros. So we'll fill this value in here. We say negative 9, 1, 2, 3, 4, 5 zeros here. And if we sum this with our 19 followed by 5 zeros, basically ignore the zeros here. We know we're going to have 5 zeros after it, but summing our two equations now, two constraints, our x's cancel out. We're left with 15 positive y's. That's equal to 9 of these 5 zero values short of 19. So we say 10, 1, 2, 3, 4, 5 zeros. So we say, okay, so now we're going to divide this by 15. So we say 10, 1, 2, 3, 4, 5 zeros divided by 15 equals about 6, it's repeating 6's, but 5 repeating 6's, and then our decimals with the repeating 6 here. So we say y. We say, okay, well then this leaves us with y being 6, 6, 6, 6, 6, 6 repeating. Now this represents the amount of dollars we invested at, if you look at your key up top, you said at 9%. The question was, how many should you invest at 7.5%? So knowing this, and this is a system of course, we say, well, they're just, we knew the total amount of dollars here in this equation here. We say x plus y equals 12 total grand in dollars. We say if we put these 6, 6, 6, 6, 6, and 6 repeating dollars back in, we could solve for x here if we were to subtract this value here from both sides. So now we say x equals that 12 grand minus that 6, 6, 6, 6, 6. So I'm just going to go ahead and say minus 12 grand. That'd be the easy way to do it here. We don't say negative, but we know we mean positive. Oops. Must have missed a 0 here somewhere. But we say x equals, dun, 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 what we got? 54666. 54666. 54666. Okay, and so that's the value we're looking for. Okay, so now let's take a look at this problem on the right. In terms of, excuse me, in terms of solving this guy, let's read through it here. We say 1 8-ounce glass of apple juice and 1 8-ounce glass of orange juice contain a total of 185 milligrams of vitamin C. The second sentence here, we have 2 8-ounce glasses of apple juice and 3 8-ounce glasses of orange juice contain a total of 452 milligrams of vitamin C. So we say how much vitamin C is in an 8-ounce glass of each type of juice. One thing that I've done here is I put in 8-ounce glass to kind of throw you off. The fact that it's an 8-ounce glass is not important, but reading the last sentence, we say how much vitamin C is in each 8-ounce glass of each type of juice. So first thing we're going to do is we're going to define our variables. So we say let x and y, of course we say number of, so let x equal number of, we say milligrams, so that's micrograms, but we say milligrams of, say, bite C and apple juice, say. And we say y equal number of milligrams bite C and OJ. We'll just go with that. So we're going to define our variables first. It's very important that we do define our variables first and then set up our equations. Now, both of these equations, if you read carefully, happen to be totals equations. So we say 1 8-ounce glass of OJ and 1 8-ounce glass of apple juice. So we say 8-ounce glass of this plus 8-ounce glass of this Actually, we have to define this as an 8 ounce of glass. That's important. But adds up to a total of 185 milligrams total. So we say, okay, so in the second equation, we say 2 8-ounce glasses of apple juice and 3 8-ounce glasses of OJ. So 2 of these, excuse me, and 3 of these add up to 452. So now that we've got our system set, we can go ahead and go about solving it. So we'll multiply the top equation. We'll do elimination method. We'll double it and make it negative so that we get negative 2x minus 2y equals negative 2 of these. We see negative 370. 2x plus 3y in our second equation was 452. So now our x's eliminate each other. We say y simply is the difference between 452 and 370. And it seems that that would be like, what, 82 positive? So we say for every y, which every 8-ounce glass of OJ, we have 82 milligrams of vitamin C. And so now, back solving for x, we could say, all right, well, x plus y in this first constraint was 185 total milligrams. So if we put 82 in here, excuse me, minus 82 from both sides, we end up with a grand total of every 8-ounce glass of apple juice having 82 shy of 185, which is 103 milligrams. So yeah, just a couple of quick examples of application problems involving 2x2 systems.